Okay, so this scale, we went 1/6 pi, 2/6 pi, which is a third, 3/6 pi, which is a half, 4/6 pi is 2/3, 5/6, 6/6 is just 1, 7/6, 8/6 is 4/3, 9/6 is 3/2, 10/6, 11/6, 10/6 is actually reducible too. That's, divide that by 2 is 5/3. Is that right? Yeah, I guess they'd write it as that, 5 pi over 3. Whoops. 11/6, and 12/6 is 2. In your question, they said they want you to graph the sine wave. I'm just going to put the limitations on it. They wanted sine theta, and if you remember how to draw sine theta, it goes up to 1, right, and down to 1. So we have all these measurements in the way, so I'll just do it with a highlighter over top. But this is our 1, up 1, and down 1. That's on our y-axis. That's the amplitude that we move across. Sine theta, so they want you to draw it with no shifts or anything, that's easy enough. They want you to put it within these boundaries of negative pi 2 and positive 2 pi. Well, this is our positive 2 pi right here, 12 pi over 6, because they told us to do it in 1/6 increments, right? Or they called it a pi increments. This is 1/6 pi increments. So it's the exact same on the way back. 11, boom. This is our negative 2 pi. I'm not going to squeeze them all in, but I'm going to do every other one, okay? So this would be 2 pi over 6. Sorry, negative 2 pi over 6. This is negative 4 pi over 6. Negative 6 pi over 6. Wait, am I doing that right? Yeah, so 8, 9, 10. Yeah, okay, good. 8 pi over 6, and this one's 10 pi, negative 10 pi over 6. So that's every other one we've done them in, okay? So, so that's supposed to be there. There, 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 there. So we only kind of went by thirds, but this guy couldn't fit everything in. Okay, so they want you to draw a sine wave. Well, if you remember, a sine wave starts at the origin. Do you remember which one of these represents 90 degrees?
Is it 1/2?
1/2, right. Yeah. So that would be this one here. 3/6 represents 90 degrees. So we can even write it down. That's technically our 90 degrees. That's when we reach up here. So we have our start of it. 180 is going to be represented by which? Do you know? Let's try to write this in a permanent color here. So I'll have it in highlighter because we're going to have to go over those numbers. Okay. We'll plot the points in red. Oh, I didn't want a straight line. That's like that. 1. That's right. So that's going to be when we finally touch down to 0 again. I guess I'm going to have to do it in. There we go. That'll be a good one to do. Let's go up. Down. 260. Do you know which of these is going to represent 260? If we think back to the circle, it's like 1 1/2, right? 1 1/2 way down the circle. So which fraction deals with 1 1/2 that we've drawn?
Is it 3 pi 2?
Yeah, 3 pi 2. That's 1 1/2, right? So technically that's our next point. So let's keep drawing. We go down to here. And finally, we end back up at our 2 when we do sine. But they want this restriction to go all the way to negative 2 pi. So we actually have to continue this graph backwards. Okay? So, in other words, our 90 degrees, which was 1, 2, 3 over. So when we go 1, 2, 3 over, that's down here. Okay? Then we get back up 1, 2, 3 over, down. So these are our points along the graph. We just continue this line that we had before. So we go down with our sine wave. Back up. Oh, I didn't draw it to the right point. It's supposed to be up to here. There we go. And down. Wasn't the nicest drawing way. But they wanted a sine wave between these 2 points, negative 2 pi and positive 2 pi. So we had to make sure, and we want it by 6 increments, that we had 12 slots all the way together. That's the only way we'd get to there. Does this kind of make sense?
Yeah.
Yeah. So that's what she wanted for that question. She wanted you to graph the sine wave. You're right. If we go to a circle, technically you're right. That's a movement of. This is a movement of 2 pi, and going the other way would be a movement of. So this is our 2 pi movement. Oh, I didn't want that. Wait. This was our 2 pi movement if we were to go this way around the circle. And if we were to go this way around the circle, you're right, that's a negative 2 pi movement. And you can be seen in the sine wave. When we started at the origin and we went to the right, we went up first, back to the start, down, and over. When we started at the origin and went negative 2, we went down first. And if you take a look, exactly what happened. We started here with the red, and we went down first. Then we got back to where we were, back up to here, and then to where we started. So we went the other way. They just want you to represent it as a continuous wave. That's why they did it over here with a sine. They wanted to look at it as a continuous wave on the graph. Does that make sense?
So what are the coordinates of all maximum and minimum points for this domain?
Okay, yeah, so let's go over all rules. Okay, so our first maximum is at negative 3 pi over 2 and 1. And our second maximum, which you already figured out, is at pi over 2. And
that's how you would write the domain?
That's the... Are they asking for the name or the coordinate?
Yeah, the coordinate of all points for the domain.
For this domain. Oh, okay. What are the coordinates of those? So these are the coordinates.
Yeah.
That's the coordinate of this and the coordinate of this. And do they want the max and the min? Okay, let's write the two coordinates first, and then we'll write the domain and range. Our minimum, so this is our max. That's one of our max. There's another max. Here's our minimums. Do you know what the coordinate of that minimum would be?
3, 6, which is like negative half pi.
Yeah. So this one's negative half pi. And what's our y value? And if you take a look, well, I'll do it in a second. Min. And what's our other minimum?
3 pi over 2.
Yep, 3 pi over 2. And
Negative 1.
Negative 1. That's right. That's our other min. Let's take a look. Just to make the similarity. If you look at this is positive pi, positive 1. That's one of our max. And our other opposite minimum is negative pi, negative 1. And then the exact same idea. Look right here. Negative pi over 2, 1. Positive pi over 2, negative 1. They're just opposites of each other.
Okay. Yeah.
Okay?
Just put 7.
Question 7?
Yeah.
I'm going to call it radians of a sine wave. Come on, computer. Oh, it's recording.